Let's take the derivative of a over x times the arctangent of x. We can start by rewriting this as y equals a times x times the arctangent of x, all of that to the -1 power. And let's differentiate both sides with respect to x. So we have derivative of y equals, and we can move this over a little bit, make some room. We can say dx of all of this. And we can actually treat this as a product rule problem where we have a as the one function, and then all of this can be considered a second function for the time being. So we'll rewrite that as dy dx equals the derivative of a times, and I'll just copy and paste this, times this, plus a times, and we'll paste that again, and we're taking the derivative of this, so times the derivative of this, and now we can go out and start taking some of these derivatives. So derivative of y equals, the derivative of a with respect to x is going to be equal to 0 because the derivative of a constant is equal to 0. So it doesn't even matter what this value doesn't even matter because it's 0 times this. So the whole that side of the equation is going to be 0 plus, and that's this plus here, plus a times the derivative of this value, which again is just this brought down here. So we can now take a look at this as a function that is nested within the -1 exponent function. So we can use chain rule here by saying u equals x times arctangent of x, and then we can rewrite this as dy dx is equal to a times, and I just got rid of the 0, so it's just this a times the derivative of u to the -1, and we have a function in terms of u being differentiated with respect to x. So here's where we can rewrite this with chain rule. I'll just move this over. So chain rule gives us du dx times du of u to the -1, and we have up here u equals x times arctangent of x. So in order to sort out what du dx is, we're actually going to, that's a fairly involved process, so I'll just indent here to keep it separate from the main equation and write du dx, where I'm just using this up here, equals, I took the derivative with respect to x at both sides, so we get du dx equals d dx of x times arc tangent of x. And let's use a product rule here to split this up a little bit. So we have du dx equals the derivative with respect to x of x times arctangent of x plus the x times the derivative with respect to x of arctangent of x. So du dx is going to equal, derivative of x is going to be equal to 1 times arctangent of x. And we can actually get rid of that 1 coefficient. Doesn't matter at this point. Move this over, give us some room to work. Plus, and that's this plus sign here, x times, and we worked out in the main derivation video that the derivative of arctangent is equal to 1 over x squared plus 1. So x times 1 is going to be equal to x. So we can move the x to this numerator here. Clean this up a bit. And we have du dx, which is this term that we're looking for. And now we're also looking for the derivative of u to the negative 1, which the derivative of, let me think of a way to write this neatly. Let's bring this whole thing down here. And we'll input du dx here. We need some more room. There we go. And don't forget that this whole thing is being multiplied. So let's get a parenthesis around this, like so. Make these parentheses matching. So now the derivative of u to the negative 1 is going to be equal to, let's rewrite this line so we can take the derivative. Here, we can rewrite the derivative of u to the negative 1 as negative 1, because that negative 1 comes down, u to the negative 2. And let's just put that u to the negative 2 in the denominator. So we have negative 1 over u squared. And to clean things up a little more, let's bring this a over and multiply by negative 1 and get negative a. And probably look better actually if we brought that to the other side. More natural looking. Make some room. There we go. So there we have a nice coefficient set up. And our u substitution that we made up here is u equals x times arctangent of x. So let's undo that. Make some more room. We're going to undo that u substitution and say x times arctangent of x. And remember it was u squared, so all of that gets squared. And where are we going to move from here? Well, first let's rewrite this x times arctangent of x squared as x squared arctangent of x squared. So we have, that's the same thing as saying x squared times arctangent of x squared. All right, and looks like we can multiply through, so dy dx is going to equal negative a times arctangent of a is going to be equal to negative a arc. Let me write that a little neater. Negative a times arctangent of x, and the denominator is x squared, because this is the same thing as arctan x over 1, so we can say multiply across and get x squared times arctangent of x squared in the denominator, and then this arctangent can cross out with one of these, so let's just do that right off the bat. So only the one arctangent was left in the denominator. And then we still have the other term, so negative a times x is going to be equal to negative a x, and that's over, same deal, the denominator is going to be, well, oh, actually, we're multiplying here. So we have x squared arctangent of x squared times x squared plus 1. So this x can cancel with one of these. Get rid of that. And let's see if there's anything else we want to do. Well, we can bring this negative here, just to clean things up a little bit. Anything else? Looks like we're pretty much done. There's nothing else that I would do here. So we are done.